Alright, so today is just lesson 1-1. It's just key features of functions. We're going to focus on looking at maybe some different points, important points of functions, domains, range, things of that nature. So we're going to start on it's actually page 1 of your notebook. We are going to look at the explore and reason. Alright, so we're going to look at average rate of change. Some of you know that as the slope of something. Interval notation, maximums, minimums, and zeros of functions in this lesson. Alright, so this is our explore and reason that we've got here. It says a diver is going through an ocean search and rescue training. The graph shows the relationship between her depth and the time in seconds since starting her dive. That's actually shown there on page 1 for you guys. It says, what details can you determine about the dive from the coordinates of the point 5, -8? Well, that is actually not A on our case. That is B, isn't it? So we'll just start there. All right, what details can we determine about the dive from the coordinates 5, -8? So we know that this is our depth, and our y-axis is our depth, or how far down we went, and our x-axis is the time it took us to get that far. So if this is at 5, -8, that means that it took the diver 5 seconds to go how far? 8 feet down, right? So it took the diver 5 seconds to reach 8 feet below the water. All right, which point on the graph shows the starting location of the diver? Would that be right here when she's on the surface? Yep. So that point would be at 1, 0, correct? Explain. This is the point where her dive, or the diver starts because the time is 0. Because it is 0 seconds. Because what is the average speed of the diver's descent? How can you tell from the graph? So what we are going to do is we're going to take 2 points and find our slope. So I know I've got a point here at 1, 0 and at 5, -8, right? I can use those 2 points that we've already. So we're going to use these 2 points, 1, 0, and 5, -8. If you don't remember the slope formula, I know it's been a while since some of you had some algebra, is m is equal to y2 minus y1 over x2 minus x1. That's our slope formula. So I always like to label my points. This will be x1, y1, x2, y2. That way I don't get confused and put the wrong number in the wrong spot. So we've got -8 minus 0 divided by 5 minus 1. So we get -8 over 4, which is -2. But could you have a negative speed? Can you? No. You can't have a negative speed. So that means that we're actually traveling 2 feet per second. Whether it's down or up, we're averaging 2 feet. Our average rate of change is 2 feet per second. Because distance cannot be negative, we are traveling an average of positive 2 feet per second. All right, we're going to actually skip part D and move down to the habits of mind. What do the points where the graph intersects the x-axis tell you about the dive? So let's look at where the graph intersects the x-axis. So that would be here and somewhere over here, right? That would be where the diver started and also where the diver ended, right? When she went below the surface and then where she came back to the surface. So for underneath habits of mind, I'm going to write that as where the diver is at the surface. All right, now actually getting into the lesson here, page 2. Understanding domain and range. Domain, remember, is your x values. Range is your y values. So in example A, they just want to know the range of the function y is equal to x squared minus 3. This one's not actually shown in your workbook. It's just shown here in the textbook. So remember, your domain again is your x values. Well, it looks like I have an ending x value right here at -3, but I go up and I see this arrow. This arrow tells me that this graph is going to keep going up. If this graph keeps going up, that means that x value is going to continue to get smaller. So that means my smallest x value would be -infinity. On the other side, on the positive x value side over here, we're going up. So this means that my positive x values are going to continue to grow. They're never ending. So that means that I have x values from -infinity to positive infinity, which is also known as all real numbers. Then you've got range. Range is your y values. I can look at this graph and tell I do not have any y values below this point right here. There are no y values down here. They stop. My y value stops here and then starts going back up. So my smallest y value according to this graph would be at -3. So that means all my y values would have to be greater than or equal to -3. So we're going to talk about two different notations to actually write this. There's set notation, and set notation uses a verbal description or an inequality to describe your numbers. write it a little different. If I even am writing it in set notation, I just I'll show you the symbol that I use in a second. I'm sure you guys have seen it for all real numbers instead of writing out those words. And then I would write it as y is greater than or equal to -3. Interval notation represents a set of real numbers by the pair of values that are its minimum and its maximum boundaries. Using interval notation, the domain of its function is -infinity to +infinity, whereas the range is -3 to +infinity. But do you see how there is a bracket around the -3? The reason there is a bracket around the -3 is because it is included. If there is parentheses, that means it is not included. So let's take a look at these right here. What are the domain and range of each of these functions? So I'm going to pull those up on my little online graphing calculator here so that we can see it a little better. We've got y is equal to the absolute value of x minus 4. First of all, I'm just going to pay attention to my x values. If I keep, I'm looking at my smallest x value, which I keep going up here, and you notice that it keeps going, right? So that means my smallest x value is going to be -infinity. My largest x value on the right side of my graph also keeps going up, so that means my largest x value is going to be +infinity. So if it goes from +infinity to -infinity, that is considered all real numbers. So let's see what we have here. We're going to have set notation. And we are going to have domain and range. Then we will have interval notation, where we will also have domain and range. Any absolute value graph that we have, your domain is always going to be from -infinity to +infinity, which, remember, I said I write it as all real numbers. You may or may not remember the sign, but that is from -infinity to +infinity. All real numbers. So actually here I told you what it should be written like in interval notation. Interval notation uses parentheses and brackets, where set notation just uses inequality symbols. You never have brackets around positive or negative infinity. You will always use parentheses there. Now let's go back and look at our graph. I look up and down to see my smallest y value. I don't have a y value until I get right here at the vertex. What is my y value of this vertex? Y value, x value is 4, so that means your y value is 0. So if my y value is 0, guys, that means all of my y values, are they larger than 0 or are they smaller than 0? Well, let's look here. What is my y value doing? Getting bigger, right? So that means all of my y values are going to be larger than 0. So I write this as y is greater than or equal to 0. Because all my y values are greater than or larger than 0, we say y is greater than or equal to 0. Well, how would I write that as interval notation? We start with your smallest value, or our minimum. Do you see how that was our smallest y value right here? We had no y value smaller than that. So my smallest y value is 0. My largest y value is infinity because it's going to keep going up. Alright, next we're going to find, instead of actually writing out set notation and interval notation, I'm just going to say SN. So we got domain, range, and IN for interval notation, which is going to be domain and range. Y is equal to 6x minus 2x squared. Alright, now we've got a parabola shape here. But if you look at my x values, I'm looking at this left side of my graph. These x values are going to continue to get smaller and smaller. It may take them a while, but they are getting smaller. The right side of my graph, though, my x values are getting larger. We go from 2 to 3, down to 4. So all those x values are getting larger. So my smallest x value is going to be negative infinity. My largest would be positive infinity. That's always the case with absolute value or parabolas. So my domain, if I write it in interval notation, is negative infinity to positive infinity. If I write it like this in interval notation, that means my domain is all real numbers. So in our first graph, we had a minimum. We had the smallest y value and everything. All our other y values were larger. This time we have a maximum. Do y'all see that? How all the y values will not get any larger than 4.5. Everything would be, all our y values would be below 4.5. And you can see that by me moving my little cursor here. So that means 4.5 is my largest y value. So since 4.5 is my largest y value, that means all the others have to be less than or equal to 4.5. So that means my smallest y value would have to be negative infinity, and my largest y value would be 4.5. I feel like you guys will be good at example 2. I'm going to just briefly hit it. It's just finding the x and y intercepts. You know, the x-intercept is where the graph crosses the what axis? X-axis, right? Those are also known as your zeros of your function. X-intercepts and zeros are the same thing. Y-intercepts are going to be where they cross the y-axis, correct? So let's take a look at example 2 here. What are the x and y intercepts of y is equal to 4 minus x squared? Alright, and this actually online graph makes it very easy for us. They put a point there at each intercept. So how many x-intercepts do I have? 2. How many y-intercepts do I have? 1. So my x-intercepts are x is equal to, let's see, what is x equal? X equals negative 2 and x equals positive 2. So negative 2 and positive 2. And sometimes they may want you to write it as an ordered pair. So if we did that, it would be negative 2, 0 and positive 2, 0. And then we had one y-intercept. Which was that y is equal to 4, or the ordered pair 0, 4. All right, example 3 talks about positive and negative intervals. For what intervals is f of x is equal to x squared minus 9 positive? And for what intervals is the function negative? So basically, it's saying that it is positive if it is above the x-axis. That's why it's in blue. So do you see how it was blue above the x, or they shaded it blue above that x-axis? And those are saying those are your positive intervals. So since this arrow tells me it's going to keep going, it's positive from negative infinity to 1 to negative 3. So it stopped right there. Do you notice how they didn't put a bracket around negative 3? The reason they put a parentheses and not a bracket around negative 3 is because at negative 3 it's not positive or negative. But starting below negative 3, do you see how it's below that x-axis? And it's below the x-axis from negative 3 all the way until positive 3. So from negative 3 to positive 3, they consider that function negative because it is below the x-axis. Then again, at positive 3, it goes above that x-axis, so they call the function positive from positive 3 to infinity because of this arrow right here. So for what interval is this function positive and negative? So let's take a look at it on the graph. Y is equal to 2x plus 10. Remember, it is positive when it is above our x-axis. And it is negative when it is below our x-axis. Let's take a look at this. We want to know when it's positive. That means when is it above the x-axis? Well, starting here at negative 5, it looks like it's above this x-axis to me, right? Are my x values getting larger or smaller? Take a look here. We go from negative 5, we go up. I got negative 3 now, then I've got a negative 2, so my x values are getting larger. Do y'all agree? So because my x values are getting larger, it is positive from negative 5. Remember, we put parentheses around it because it's neither positive nor negative at negative 5. So from negative 5 to positive infinity, it is positive. And then they want us to now say when it is negative. When is it below that x-axis? Well, it's below the x-axis from negative 5 down, correct? Well, if we're going down, we're getting smaller, so that means it's really negative from negative infinity to negative 5. Negative infinity to negative 5. Alright, so they had us look at the positive or negative. Now we're going to look at when the function is increasing or decreasing. For what values of x is g of x And it gives you the function 2 minus the absolute value of x increasing. And when is it decreasing? So we read the graphs left to right. So if you read a graph left to right, if I'm starting over here, I'm obviously going up until I hit this vertex. Do y'all agree? If I was reading that graph left to right, I would be going up. So if I'm going up, that means that I am increasing. If I start going down, that means I am decreasing. It says the point at which the function changes from increasing to decreasing is called your maximum. If the point at which the function changes from decreasing to increasing, that would be called your minimum. So if this graph was flipped over, we'd have a minimum, but because of it opens down, that means it is a maximum. So we're going to look at each function to tell whether or when it is increasing and when it is decreasing. So let's see if I can do this real quick. We got y is equal to x squared minus 4x. Y is equal to negative 2x. Alright, we're going to do one at a time. I just wanted to go ahead and get both on here. And now I'm actually going to take a small screenshot of this so I can draw on it. Alright, so here is my graph. And I've got a vertex at 2, negative 4. Sometimes it's just better to have a visual to be able to draw on. I've got a vertex here at 2, negative 4. And if we read our graph from left to right, so I'll come down this way and I go to that either maximum or minimum. I'll go to that where we change directions. We stop there. How did I go there? Was I going up or was I drawing down? I was drawing down, right? So because I was drawing down, that means that I am decreasing. Yep. So now at negative 2 to 4, or at 2, negative 4, excuse me, I changed directions and now I'm going up. So that means I am increasing. I was decreasing as I started my graph, and I will be increasing as I finish it up. So I'm going to write increasing and decreasing. I'm going to do it for both, actually. Alright, so let's get back to here. We look at our x-axis. So we were decreasing from negative infinity to positive 2. That was my decrease, from negative infinity to positive 2. I was decreasing, negative infinity to positive 2, because we were just paying attention to our x values. Negative infinity, positive 2. However, at that minimum, I switched directions. And once I changed directions, I started increasing. So because I am increasing, I start at positive 2 and I finish increasing at infinity. So from positive 2 to infinity, I am increasing. Alright, here's my other graph. increasing and decreasing. If I look at this graph and I start on the left side, do I ever have a change of direction? Oops, I can't draw a straight line. I can't even trace a straight line. No, I'm just going down the whole time, right? You see how I'm continuously decreasing, right? This graph never goes up, does it? So I'm just decreasing from negative infinity to positive infinity. Well, when do we increase? I just wrote never. I'm going to skip that habits of mind there, guys, and look at our last graph. Or our last example. What do the average rates of change for the function, the absolute value of x plus 2 over the intervals, indicate about our function? So let's actually see what the book says first before we try to dive headfirst into this problem. Alright, so basically, average rate of change, they put that in a funny way, but that's just your slope formula. I don't know why they put it like that. And in part B is where they start talking about the given functions. So, the average rate of change for this first function, f of x is equal to 1, that was a straight line. It had a slope of 0 each time. Alright, so since our slope is the same each time, we're going to keep that in mind by looking at the second one real quick. They got our average rate of change here. They got a 1 half, 1 half, 1 half. Do you notice how that is the same each time? Since it does have a constant rate of change, 1 half over here was 0. This means that the function is linear. So it was a straight line. That's all that means. Is it linear or not? So now they have us with, or then they show you a parabola here where we got a rate of change from negative 2 to 0. So negative 2, 4, and 0, 0. They got negative 2. But from 0 to 3, they got a slope of 3. But from negative 2 to 3, they got a completely different slope. They got a slope of 1. So since it does not have a constant rate of change over every interval, that means it is a non-linear function. It's not a straight line, which is what we can actually tell by looking at our graph. So what do the average rates of change of the function y is equal to the absolute value of x plus 2 over the intervals indicate about the function? Is it linear or not is basically what we are trying to decide. So if I look at my intervals, negative 2 to 0, negative 2 to 0, and if I didn't want to look at the graph, if I didn't have a way to graph this or something to tell whether it was linear or not, what I would do is I would just look at my table. So what I need to do is I'm going to put in this equation. And we can obviously see here that it is not linear. You could probably have told me that by looking at the equation itself. But what I'm going to do now is just use our information from our table to figure out if it's linear or not. So they're asking from intervals from negative 2 to 0. So at negative 2, my y value is 4. At 0, my y value is 2. So those are my 2 points that I'm going to use to get a slope. At negative 2, my y value was 4. And at 0, my y value was 2. Remember that slope formula, y2 minus y1 over x2 minus x1, where we've got x1, y1, x2, y2. So my average rate of change from negative 2 to 0, I would say 2 minus 4 over 0 minus a negative 2. Well, that's -2 over +2, which is -1. So that means my average rate of change from -2 to 0 is -1. All right, now let's find our average rate of change from the intervals 0, 3. Well, we know at 0, my y value is 2. And by looking at my table over here, at 3, my y value is 5. So again, I'm going to find my slope, x1, y1, x2, y2. So m equals 5 minus 2 over 3 minus 0. So that's 3 divided by 3, which is just 1. So from the interval 0 to 3, my average rate of change was 1. Now our last interval, from -2 to 3. What is our average rate of change? Well, I've got -2, 4, and 3, 5. Again, we're going to use that slope formula, x1, y1, x2, y2. So 5 minus 4 divided by 3 minus the -2. And that gives me 1 over 5. So do you notice how my rate of change, or my average rate of change, is completely different for all 3 intervals? Since the rate of change varies, that means the function is non-linear. And I know you may have run out of some room, so if you want to put or cross this out so you have some room to write. So I'm going to say, since rate of change varies, the function is nonlinear. Right now, I want you guys to turn to page 4. I'm going to go ahead and tell you, I am not ever going to assign anything that is under this part right here. Do you understand? That will never be assigned to you. So tonight, I only want you to do these. It's just all the key features we talked about: domain, range, x-intercepts, y-intercepts, intervals if the graph is positive, where it is decreasing, where it is increasing, and the rate of change. So I want you to try your best on these. I will come around tomorrow at the beginning of class and check to make sure you did them, okay? And I would do that every day with these Do You Know How problems. So you've got, what is that, 25 minutes. You can probably knock it out today. That way you didn't have anything to do tonight.